Good evening, everyone. It is once again Ted the Speed Learner, and tonight I'm going to continue my video series on thermal acoustics. Okay, this is part 2. And before I do, I want to tell everybody that I have published 5 Kindle books, and if you're interested in any of them, you are more than welcome to leave a comment down here in the comments below, and I'll send you a link to those books. You can buy them and you can take a look at them, okay? But without any further ado, let's continue. In a previous video, I showed you what a helix looks like. Now I will tell you how this information will apply to thermal acoustics. Sound waves are based on air pressure. Sound waves create points where air particles are compressed together. At other points, air particles are spread out. The areas where air particles are compressed together are called compressions of sound. The areas where air particles are spread out are called rarefactions. Where did the term rarefaction come from? Okay, the word rarefaction comes from the Latin word rarus, which means rare, and the Latin word facere, which means to make or produce. In this case, we are creating low air pressure when we spread out air particles. When we create air compressions and air rarefactions, we create sound waves. When you place a heating element in a specific position inside a PVC pipe, it will create a continuous standing sound wave. This creates the helix that I mentioned earlier. Now, what kind of helix are we talking about? You're talking about a rotating helix? Well, let me show you what a rotating helix is going to look like. Do you remember when I talked about parabolas and Pappas Book 7, Proposition 238? Yeah. Bet you should check that out right now. Okay, so what you have here is your pipe. And when you start generating sound waves, this center dot right here is going to start forming a rotating helix. Okay, when you start generating sound waves, that's going to form a rotating helix. And what's going to happen is that these two curves, which should look like a parabola, okay, will turn around like a screw. Okay, it'll turn. Okay. Now, a standing sound wave starts at a fixed point. Then it travels to another fixed point. So in other words, a sound wave starts at a stereo speaker and it goes to the other end of a pipe and then it gets reflected back. Okay? And when this reflection happens back and forth, that's a standing sound wave. Okay? So let's imagine the crest of a sound wave traveling from one fixed point to a second fixed point. Okay. Now, by the way, there is a link to a video in the description of this video that will show this a lot better than I will. So please check that out. Okay. Now, this is not going to be a perfect drawing. There you go, sound waves. Okay. Now, what is the crest of a sound wave? Well, let me erase this for a second. the crest of the sound wave is going to be right about here. Okay? Now then. So, this sound wave, the crest of it's going to move across here and eventually it's going to reach the other side. Now you have to imagine the crest of a reflected sound wave traveling from the second fixed point to the first one. So, okay, here's your reflected sound wave. The crest would be right about here. Okay. Now then, this sound wave and this reflecting sound wave meet at this fixed point. And this is where you're going to start getting your helix. Okay? Now, if you need a real illustration of standing sound waves, you should take a guitar and pluck one of the strings, and you'll see it for yourself. So far, so good. But how is any of this information going to produce heat? Well, the first thing you have to know is that when you compress air, guess what? It generates heat. So that's a good clue as to how we're going to do this. Okay? Now, we know that in this particular tube, we were using heat to generate a sound wave. Okay? Now, we also know that by convection, if you watch the video that we got linked down here below, if you watch that, you will see that as heat rises through the pipe, what's underneath is cold air. That's what you can use for your air conditioning. Like, interesting. But this is not done. Okay, so I'm going to tell you more in a future video, so I'd like for you to stay tuned.